Hello everyone. In this video, we're going to generalize the first part of the fundamental theorem of calculus, and we're going to find a formula for the derivative of this integral with respect to x, where the limits of integration are functions of x. And we're going to use our formula to find the derivative of this integral with respect to x. Let's get started. Let us first recall the part 1 of the fundamental theorem of calculus. So this part 1 states that if you have a function that is continuous on a closed interval ab, then this function g defined by this integral from a to x, where x is from a to b, is also continuous on the closed interval ab, and it is differentiable on the open interval ab, and its derivative, so that is the derivative of this integral with respect to x, is just equal to the function value of the integrand at the upper limit x. So that is equal to f of x. Now, in this video, we're going to derive a formula for the derivative with respect to x of this integral if these limits of integration here are both functions of x. Let's find a formula for such problems. Let u be equal to a function of x, h of x. Then, the derivative with respect to x of this integral here from a to u of f of t dt is equal to, keep in mind that this integral here is a function of u, and if we are differentiating with respect to x, if we're going to apply chain rule, then we first have to find the derivative with respect to u of this function of u here, and then multiply it with the derivative of u with respect to x. So this is just an application of chain rule. And from the first part of the fundamental theorem of calculus, this derivative with respect to u of this integral from a to u of f of t dt is just equal to the function value of the integrand at u, which is the upper limit of integration. And because our u is equal to h of x, therefore, this derivative here from a to u, where u is equal to h of x, is just equal to the function value of the integrand at the upper limit, which is equal to h of x, and then times the derivative of this upper limit of integration with respect to x. Now, let's use this result to find a formula when this a here is replaced by a function of x. So when we take the derivative of this integral here with respect to x, now we have limits of integration that are functions of x. So first, we're going to split this integral into sum of integrals. So splitting it at x equals a, so we have here integral from g of x to a, and then plus integral from a to h of x. Now, so that we can apply our result here for this integral here, we're going to interchange the limits of integration. But of course, when we interchange the limits of integration, we have to multiply that by -1. And now we can already apply this result here to compute the derivative of this integral and also the derivative of this integral. So applying this result here, we'll get the derivative of this second integral is just equal to f of h of x times h prime of x, and then minus the derivative of this integral here, which is equal to f of g of x times g prime of x. Therefore, to find the derivative of this integral here with respect to x, all we need to do is first replace this t by h of x and multiply it by the derivative of the upper limit, and then minus, replace this t by g of x, and then multiply it by the derivative of g of x. Let us now use our formula to find the derivative of this integral here with respect to x. Let us first recall our formula. So if we're going to apply this, then we'll get here the derivative of this one. So first, we replace the t by the upper limit of integration, and we'll get this one here, and then multiply it by the derivative of that upper limit of integration. And then minus replacing the t here by e to the x, and we'll get this one, and then times the derivative of the lower limit of integration. And we'll get here derivative of sine x is equal to cosine x, derivative of e to the x is equal to e to the x. Therefore, we can write our final answer as cosine of x times the square root of this, and then minus e to the x times square root of this one. I hope you enjoyed this video. Please don't forget to like, share, and subscribe to help me grow this channel. Thanks for watching, and I hope to see you next time. Bye bye.